A 100 kilogram box is pulled with a force of 1,000 newtons. If the box is just starting to move, in other words, we're at the maximum value of static friction, what is the coefficient of static friction? Well, mu sub s is equal to Ff over Fn. Our force is 1,000 newtons. Our force of friction, excuse me, our normal force, Fn, is really the positive value of mg, because there's nothing to indicate that this is anything other than a horizontal or level situation. So that's going to give me 100 times a positive 9.81 newtons. So I have 1,000 newtons over 981 newtons, which is going to give me a coefficient of static friction of approximately 1.02. Now the units, newtons over newtons, will cancel. The coefficient of friction is in fact a unitless or dimensionless unit or value, because it is in fact a pure ratio. A 250 kilogram crate is pulled with a force of 2,500 newtons and accelerates at 3.5 meters per second. Determine the coefficient of kinetic friction. Well, we know that the net force is equal to the mass times the net acceleration. It's a 250 kilogram crate with a net acceleration of 3.5. So we have 875 newtons for the net force. The total force is the force of friction plus the net force. Total force we know is 2,500 newtons. We do not know what the force of friction is, but we know the net force is 875. So that gives us a force of friction of 1,625 newtons. Since we know that the coefficient of friction, mu sub, in this case it's kinetic friction, so mu sub k is equal to the force of friction divided by the normal force, 1625 divided by, well, in this case, the normal force is going to be 250 times 9.81. So that gives us a coefficient of friction of approximately 0.66. Again, there are no units on coefficient of friction. If a boy weighs 475 newtons on Earth, what is his mass? And what is his weight on Mars? Well, if his weight is 475, we know that the force is mass times gravity. You can think about it as a negative because gravity does pull down. Earth, we have the 9.81. So we have a mass of 48.4 kilograms. Then on Mars, we can simply take that same mass and multiply it by the acceleration due to gravity on the surface of Mars, which gives us a weight, and I'm putting a negative on here just to emphasize that it's down, of 179 newtons. A crane is raising a 250 kilogram crate at a constant velocity. What is the tension in the cable? So if it's a constant velocity, you know that the acceleration overall is 0. So here we know that the force of tension, and I'm actually going to write the word tension as a subscript, is equal to the weight, except it's opposite in direction. Sometimes you will see it written as the sum of the forces is 0 in this case, which is not an inaccurate statement. In some ways it's cleaner. So if I say F of tension is equal to the absolute value of mg. It's a 250 kilogram crate, 9.81 meters per second for the acceleration due to gravity. That gives me 2453 newtons. That's the tension. That's the upward pull on the cable. If the net acceleration is 2.75 meters per second, then we can say that F tension plus F weight is equal to your total force, which is equal to mass times the net acceleration. Well, I know that weight is a 2453 Newton force going down. It's still a 250 kilogram object, and my net acceleration is 2.75. So my tension is 3,140 newtons. A simple pulley is used to redirect the weight of a 2.5 kilogram block to provide constant tension to the box. What is the largest box that can just resist the tension of mu equals 0.349? Well, what this looks like is essentially you have a box, you have a pulley, a simple pulley. They're connected to a surface, and you have say a rope going down, or it could be going up, whichever way. It's being used to redirect. Mu 0.349. So what we know then is the maximum force of friction, because this is static friction. Mu sub s is equal to the force of friction over the normal force. So 0.349 equals the force of friction over, well, the normal force, since this is a vertical situation sitting kind of on a tabletop or something, mass times the absolute value of acceleration, since it's going up, 9.81, 0.349 equals FF over 24.5. So your force of friction, the maximum, is about 8.56 newtons. Once you exceed that value, then the box will start to slide along the table.